the first question says the exact value of log base 64 of 8. I am going to show some work so I can show you guys what we're getting, but yeah, so yeah, Zane. So the midterm will be taken through Gradescope. So what I mean taking the Gradescope is that so when the midterm becomes available, the PDF file, which will look very so your midterm will look very similar to this. Show me here. So this PDF, so when you go into Gradescope, when you start the exam, the first thing you'll do is you'll download this PDF, and you can either print it out if you want to. You don't have to print it out, or just write down your answers on your own paper. But you will have this whole thing available to you once you start the exam in Gradescope. And then when you're done, you're going to take pictures, right? Scan pictures of your answers into your phone, presumably, or if you have a scanner, that's a scanner. I should know how to scan it. You're going to take pictures of your answers on your phone, most likely, and then upload them to Gradescope just like you would a homework assignment. You will have an hour and 20 minutes plus another 20, sorry, not an hour and 20 minutes, 2 hours, which is 120 minutes, plus another 20 minutes for the scanning and uploading. Other questions? No, of course, you're welcome. Yeah, happy to answer them. But yeah, you will not be typing answers into Gradescope like you have in for quizzes. So to answer this question, so if you're taking the test, you're welcome to just write the answer is 1/2. But the work you might need to do to get there on your own, which you don't have to show me, is to say, oh, well, log base 64 of 8 equals x, 64 to the x power equals 8. And then you can write both sides as powers of 8. 64 is 8 squared. 8 is 8 to the first. So 8 to the 2x equals 8 to the first. So 2x equals 1. X equals 1/2. But again, right, this problem you don't have to show any work. So if you just know that the answer is 1/2 because you know it, that's also fine. Next one, what's the y-intercept of the function f of x equal to 5x squared plus x plus 1? Okay, y-intercept is just the place where we hit the y-axis, which is when x is equal to 0. So we're going to set x equal to 0. And f of 0 is going to be 0 plus 0 plus 1, which is 1. So the y-intercept will be 1. Sorry, things around here. I don't always covering up the chat. Okay, cool. Not that anyone's great. Yeah. Next one. I guess I should number these, right? Let's be precise. The next one is the center of the circle and the radius of the circle, and I'll write the equation. So the equation is x plus 6 squared plus y minus 2 squared. And it was supposed to be equal to 9. So the center is -6, positive 2. Say the things that you write the things that you say. -6, positive 2. Yes, I will be having office hours tomorrow at the usual time of 10 o'clock. Center is -6, positive 2. Radius is the square root of 9, which we should simplify is equal to 3. But if that was like 10, the radius would be the square root of 10, and that's just it. I will also point out, don't give me decimal approximations on your test unless asked. You're just saving yourself time if you don't do that, right? Unless they're asked. Okay. And I also have office hours today at 3 p.m. Vertex of the parabola, y equals to 3 times x minus 2 squared. The vertex. So this one has been written in the vertex form, so we can readily read the vertex. The vertex is the value of x that makes this 0, so positive 2, and then this is the value of y. That's all we have to do. You could do more work, right? You could totally, if you wanted to, multiply this out. say 3 times the x minus 2 squared is x squared minus 4x plus 4 minus 6, and then distribute the 3. This is way too much work for this problem. And then add those together. And then say, okay, the x coordinate is negative b over 2 times a, which is 12 over 6, which is 2. And then the y coordinate, you plug in x equal to 2, you get 3 times 2 squared minus 12 times 2 plus 6, which is 3 times 4 minus 24 plus 6, which is negative 12 plus 6, which is negative 6. You should not do it this way if it's given to you like this. But you could, but you shouldn't. Okay. So yeah, if you're given the parabola in the vertex form or the completed square form, the vertex can be read automatically just by looking at it. So this is the general theme whenever I teach. Don't do more work than you have to do. Certainly do work if you're asked to do it and show your work if you're asked to, but don't do unnecessary work if you don't have to. I know it's easier said than done, right? It does take practice to kind of know what we need to do and what we don't need to do, but try to avoid doing extra work if you can. What's the exact value of log of 10? So when we write log, L-O-G, the base is base 10. So this you could rewrite as log base 10 of 10, and that's just going to be 1. All right. So that was number, sorry. Keep forgetting to write the numbers, that was number 5. Number 6. In the equation, A equal to P times 1 plus R over N T power. And this is the, oh my gosh, words. The compound interest formula. Not continuously compounded, right? The continuously compounded is the P e to the RT. But for compounded N times per year, this is the formula. So in the equation, interest is compounded weekly with a 13% interest rate. And the question is, if that's the case, what is N equal to and what is R equal to? Well, N is the number of times per year that we're compounding. So if we're compounding every week, we're compounding 52 times per year. So N is 52. And the interest rate, so I should say, if the interest rate is 13%, then R is that interest rate as a decimal. So not 13, but 0.13. That's it. The next one, number 7, rewrite 7 to the x equal to 20, oh, sorry, not 7, 4 to the, I'm going to look at the number and see if this is wrong. 4 to the x equals 29. Rewrite that as a logarithmic equation. So the idea here is that we've got the base of 4 to the x power equals 29. We can rewrite that as log base 4 of 29 equals x. That's it. That's all we're being asked to do. And the last one on this page, true or false, x plus 3 squared equals x squared plus 9. And that is false. You don't need to say anything more, but if you did want to say more, you could say it's clearly false. You could either say it's false because we'll pick any number for x that isn't 0. Like say, what if x was 1? 1 plus 3 squared is 4 squared, which is 16. 1 squared plus 9 is 1 plus 9, which is 10. Or you could go for the more general idea. If you multiply out x plus 3 squared, x plus 3 squared is actually x plus 3 times x plus 3, which is x squared plus 6x plus 9. So false, right? You don't need to say any of this stuff. All you have to say is false, but just be aware that this is false. All right, next page. Next page, yes. So the beginning of the next page, it does say, for the remainder of the problems, you must show your work in order to receive credit. So please do show your work for the problems that say you have to show your work. So let's see here. Find a numerical answer for x. So the question is log base 4 of the cube root of 16 is equal to x. And people have been doing problems like this in many different ways. It's perfectly fine as long as you show your work and it's valid. The way I would probably do this one, actually there's a couple ways I do this one. Let me show you 2 ways, excuse me, to do this one. First way, rewrite it as 4 to the x equals the cube root of 16. And then 4 to the x, this is 16 to the 1/3. And then we can write both sides as powers of 4. This is 4 to the x, this is 4 to the second to the 1/3. So 4 to the x equals 4 to the 2/3. So x equals 2/3. It's a perfectly fine way of doing it. Alternatively, you could say x equals log base 4 of cube root of 16. We can write as 16 to the 1/3. Then we can bring that power down in front. So x equals 1/3 log base 4 of 16. Log base 4 of 16, I am perfectly fine with you jumping to the conclusion that's 2, right? It's pretty obvious that 4 to the second power equals 16. So log base 4 of 16 is 2, and then 1/3 times 2 is 2/3. Either way, perfectly fine. Or some other way, as long as it's valid and you show your work. All right. I'm going to try and erasing behind the door. You can stop me if you have any questions. Let's see what I got here. To find the equation of the line to the points 1, 3, and -7. So here are the points 1, 3, and -7. We want to find the equation of the line. I did not specify what form, so you can write it in any form you want. Meaning, you can write it in the y equals mx plus b form, which I imagine is what most people prefer. You could also write it in the point slope form. Y minus y1 equals m times x minus x1. Either way, perfectly fine. So to do this, we need a point. Great, we got 2 of them, we're set. We need a slope. We need to find the slope. So the slope is going to be the difference in the y's divided by the difference in the x's. Or more specifically, the equation is y2 minus y1 over x2 minus x1. It does not matter which one you think of, x1, y1, which one you think of as x2, y2, as long as you're consistent. So I'm going to do these ones minus these ones. So I'm going to do it as the y's. So make sure you pick the y's on top, right? So it's 3 minus 7 divided by, since I did 3 minus 7, I have to do 1 minus -2. So 3 minus 7 is -4. 1 plus 2 is 3. So there's my slope. Then we can write the equation of the line. You can use the point slope form. You can do this. You can say y minus, pick either point. Let me pick this point. Y minus 3 equals -4/3 times x minus, the same corresponding point, 1. You can leave it like this, or you can solve for y. Y equals -4/3 times x minus 1 plus 3. I added the 3 to both sides. And I'm going to distribute the -4/3. Y equals -4/3 x. -4/3 times -1 is +4/3. I'm going to write 3 as 9/3 so I can add those fractions together. So y equals negative 4/3 x plus 4/3 plus 9/3 is 13/3. So that would also be perfectly fine. Alternatively, if you prefer, you can find the y equals mx plus b form a different way. I usually do it this way, but you can also just start with y equals negative 4/3 x plus b, and then plug in either one of these points. Let's plug in the other point that we didn't use. So I plug in 7 for y and negative 2 for x. We can then solve for b. So 7 equals negative 4/3 and negative 2 is positive 8/3. Subtract 8/3 from both sides. So 7 is 21/3 minus 8/3 equals b, and 21 minus 8 is 13. So 13/3 equals b. So we end up getting y equals negative 4/3 x plus 13/3, which is the same thing we got right there. So either way you do it, you'll get the right answer. You should just do whatever works for you. All right. Okay, so what's up next? Question 11. That's too much. All right, question 11. Use properties of logs to simplify the expression to a single logarithm and then to numerical ones. So here's what we've got. Log base 4 of 6 plus 3 log base 4 of 2 minus 1/3 log base 4 of 27. Now I want to point out, we could, although we shouldn't, but we could simplify log base 4 of 2 to be 1/2, because 4 to the 1/2 power is equal to 2. However, the question specifically says use properties of logs to simplify the expression to a single logarithm. And if we write this is equal to 1/2, we can't really write the whole thing as one logarithm. So we're not going to do that, even though it's something we could do. So let's see. Log base 4 of 6 plus I have to bring up these coefficients as powers. So I'm going to have log base 4 of 2 to the 3rd minus log base 4 of 27 to the 1/3. 2 to the 3rd is 8. 27 to the 1/3 power, the cube root of 27 is 3. So this is log base 4 of 6 plus log base 4 of 8 minus log base 4 of 3. And then we can combine that into one logarithm. That's going to be log base 4 of 6 times 8 minus log base 4 of 3. Which, although you could multiply that 6 times 8, it's actually not in our interest to do so. We could, it's 48. But it's going to be easier to simplify this if we don't. It's going to be log base 4 of 6 times 8 divided by 3. And then instead of trying to do 48 divided by 3, which is not easy to do, we can say 6 divided by 3 is just 2. So that then we have log base 4 of 2 times 8, which is 16, and log base 4 of 16 is just 2. All right.
James, will there be any cases where we won't get an exact, like we can't raise it to an exact power? So right here we got 2, but
Not if I was asking you to simplify it like this. Like there might be other, like actually the next question we're going to answer is not going to look very nice. But no, like I could do something slightly more challenging where you ended up with something like, I don't know, log base 9 of 27, where the answer is not an integer, but it is still relatively straightforward. This ends up being 3 halves, because 9 to the 3 halves power is equal to 27. But no, I probably wouldn't give you something where it's just like if your answer was like log base 4 of 7, right? That would just be your final answer. I probably wouldn't give you something like that in a problem like this.
okay, thank you.
You're welcome. Also, the next question, 10 to the x plus 3 equals 7 to the x. And here, specifically since we have a 10 as one of our bases, I'm going to use log base 10. So now log of 10 to the x plus 3 equal to log of 7 to the x. Right, the base is 10. You can write base 10 if you want. You do not have to write base 10 if you don't want, but just be aware that the base is 10. So I'm going to bring down my powers, and then x plus 3 times log of 10. Log of 10 is just 1. Equal to x times log of 7. So this is just 1. And 1 times anything is just whatever you got over here. This is just x plus 3 equal to x times log of 7. So I'm going to try solving for x. So I'm going to bring all my x's to one side. Since I already have an x on the right and I don't have any non-x terms on the right, I'm going to bring my x's to the right. So I'm going to subtract x on both sides and say that 3 is equal to x times log of 7 minus x. And then to be able to solve for x, we have to factor out an x. So I'm going to say 3 is equal to x times this. When I divide out an x, we just look with log of 7. And this, when you divide out an x, we're left with 1. So then we would get, if I divide both sides by log of 7 minus 1, I get 3 divided by log of 7 minus 1 equal to x. That's our answer. And this is an example of a question where I do not want you to give me a decimal approximation. That's our answer. We're done. There are certainly other ways to write this. You can use a different base. That would be perfectly fine. But your answer is going to be something like this. It would also be fine. Do I really want to say that? No, I don't really want to say that.
James, can you go over the last step, please?
From here to here?
Yeah, where you, like, I'm just wondering where you got the 1 from.
From here to here.
Yeah, right there.
So we'll think about it this way. If I multiply the x back through, I have to distribute. X times log of 7 is x times log of 7. X times -1 is negative x. So when I divide out an x, I'm really dividing. I'm dividing my x. This divided by x is log of 7, and this divided by x is -1.
Okay, thank you.
Wrong. Let's do another one of these just because I feel like I could probably ask you one of these where both of the bases are not 10 or even. So let's say we had something like 5 to the 2x minus 1 equal to 7 to the x plus 6. You certainly could use log base 5 or log base 7, but that's fairly unstandard. Or not standard. It's not what's right. That's not the usual way of doing it. Not that you couldn't, and I'll probably show you that as well. But I would typically use natural log if I didn't have a 10 or even if I did have. So I'm going to have the natural log of 5 to the 2x minus 1 equal to the natural log of 7 to the x plus 6. We're going to bring down the powers. X minus 1 times the natural log of 5 equal to x plus 6 times the natural log of 7. In each of these cases, we have to distribute the natural log of 5 and the natural log of 7. So this multiplies by both of those things. This multiplies by both of those things. So I get 2x times natural log of 5 minus 1 times natural log of 5 equal to x times natural log of 7 plus 6 times natural log of 7. This is where, again, we're going to bring all the x's to one side and all the non-x's to the other side. I'm going to bring my x terms to the left. So I'm going to subtract this from both sides. So it will go away over here. It will be 2x natural log of 5 minus x natural log of 7. I'm going to add natural log of 5 to this side. So you have plus natural log of 5 plus 6 natural log of 7. Just like the previous example, I'm going to factor out the x. So if I divide out or factor out an x, here I'm left with 2 natural log of 5. Here I'm left with 1 natural log of 7. Still equal to natural log of 5 plus 6 natural log of 7. Finally, I'm going to divide both sides by what's multiplying x. So I'm going to end up getting x equal to all of this, natural log of 5 plus 6 natural log of 7, divided by all of that. 2 natural log of 5 minus natural log of 7. And I would really encourage everyone to just leave it like this. You do not have to do any further simplifying. I know definitely some people in one of the homework assignments or maybe a quiz like brought the 2 up as the power here and said like the bottom was the natural log of 25 over 7. That's not wrong, it's just not necessary. If you do that, it's fine, but if you don't do it, it's also fine. Alternatively, you could solve this one a slightly different way. Let me write it on the other side. Right, so I will say with these log problems especially, there's usually multiple avenues to get to the right answer. But if we had that same question, 5 to x minus 1 equal to 7 to the x plus 6, you could rewrite it as a logarithmic equation with whatever base you want. So you could say, oh, right, 5 to the 2x minus 1 equals 7 to the x plus 6. So all of this is equal to 7 to the x plus 6. So I could say that, right, 5 to what power equals 7 to the x plus 6? Well, it's the 2x minus 1 power. Right? You could rewrite it like this, where it's 5 to this power equals this stuff. Oh yeah, that's the same equation. And then you could bring this out in front. So x plus 6 times log base 5 of 7 equals 2x minus 1. You still have to solve for x though, meaning you still have to get all the x's together. So here's the thing, if you're solving for x, x can't be in your answer. So I still have to distribute this and say I've got x times log base 5 of 7 plus 6 times log base 5 of 7 equals 2x minus 1. Bring all the x's to the same side. Let's bring all the x's to the right this time. So I'll subtract this over here. So we'll have 2x minus x times log base 5 of 7 equal to 6 times log base 5 of 7, and then add the 1. And then you factor out an x. So you've got 6 times log base 5 of 7 plus 1 equal to x times 2 minus 1 times log base 5 of 7. And then finally, divide both sides by this. So that x is equal to all of that, 6 times log base 5 of 7 plus 1 divided by 2 minus log base 5 of 7. That's also a perfectly fine way, although weird to me, but still a perfectly fine way of doing it. Yeah. Oops, I just got pen on my desk. But the thing I want to point out here is at this point, you can't just like say x plus 6 equals 2x minus 1 divided by that and then subtract 6 because you've got x's in your answer for x. So if you're solving for x, there can't be x's in your answer. All right. I keep trying to hit the space bar and I have to click on the thing first. So that was number 12. Let's go to number 13. Lucky number 13. So sketch the graphs of the following equations listed below on the same coordinate system. Be sure to find all the points asked for below. So we've got y equal to x squared minus 2x plus 3. And we've minus 3. And we've also got y equal to negative 2x plus 1. And for this one, we're asked for the vertex, the y-intercept, and the x-intercept. For that one, we are asked for the x-intercept and the y-intercept. So let's go ahead and find the stuff for this parabola first. So the vertex, let's find the x-coordinate. Negative b over 2a, negative 2 over 2 times 1 is 2 over 2, which is 1. The y-coordinate, we're going to plug in 1. We're going to get 1 squared minus 2 times 1 minus 3. 1 minus 2 minus 3 is minus 4. Right, 1 minus 2 is negative 1. Negative 1 minus 3 is negative 4. So my vertex is the point 1 comma negative 4. The y-intercept, if we set x equal to 0, we get y equal to 0 minus 0 minus 3. So my y-intercept is the point 0, negative 3. X-intercept is a little more work. Find the x-intercept, we set y equal to 0. So if y is 0, we have 0 equal to x squared minus 2x minus 3. This does factor. It factors as x minus 3 times x plus 1. So our solutions are x equal to 3 and x equal to negative 1, which means our x-intercepts are 3, 0, and negative 1, 0. So that's all the important information for the parabola. For the line, we just want the x-intercept and the y-intercept. So the y-intercept, again, we're setting x equal to 0. We're getting y equal to 0 plus 1 is 1. So 0, 1. For the x-intercept, we're setting y equal to 0. So we get 0 equal to negative 2x plus 1. I'm going to add 2x to both sides, divide both sides by 2. So the x-intercept is the point 1/2 comma 0. So now we have most of the things that were asked for except for the intersection points. So to find where two graphs intersect, we set them equal to each other. So we're setting we're going to set x squared minus 2x minus 3 equal to negative 2x plus 1. And then we're going to bring everything to one side. I'm going to bring everything to the side where x squared will have a positive coefficient. So I'm going to bring everything to the left. So I'm going to add 2x to both sides. And I'm going to subtract 1 from both sides. So I end up getting x squared minus 2x plus 2x is 0x. Minus 3 minus 1 is minus 4. Factor x minus 2 times x plus 2 equals 0. So x equals positive 2 or x equals negative 2. But I don't just want the x values, I want the intersection points, meaning I should find the corresponding y values. So these are my equations, right? Y equal to this and y equal to this. So I should be able to plug in 2 back into either one of these and get the same y value. If I plug in 2 here, negative 2 times 2 is negative 4, plus 1 is negative 3. So this gives me the point 2 comma negative 3. It's also what I would get if I plugged in 2 here. If I plug in 2 here, I get 4 minus 3, which is negative 3. And then I'm also going to get negative 2. So if I plug in negative 2 here, negative 2 times negative 2 is positive 4, plus 1 is positive 5. Which would be the same thing if I plugged in negative 2 here, I would also get positive 5. Right? That's how we know they're intersection points, because you get the same x and y coordinate for either graph. I want to point out We're not graphing x squared minus 4. That's just the equation we got when we're trying to find the points of intersection. We're graphing y equals x squared minus 2x minus 3 and y equals negative 2x minus 1. Plus 1, sorry. And so let's see, here's what we know. Let me draw myself some lines here. 1, 2, 3, 4, 5, 6, sure. So let's see, if I'm graphing the line we know had points of intercepts that were y equal to 1 and x equal to 1/2. We also know that we have these points of intersection, so we should probably try and graph those as well. We got the point 2, negative 3, and the point negative 2, 5. One, two, three, four, 5. And there should be a straight line. So if it's not a straight line, try and fix it so it is. Sure, that's pretty good. The parabola should also go through this point and this point, the points of intersection. And the parabola, if you recall, had a vertex of 1, negative 4, a y-intercept of negative 3, and x-intercepts of 3 and negative 1. So we have a vertex of 1, negative 4. That should be the lowest point that opens upwards. We have a y-intercept of 0, negative 3, and x-intercepts of negative 1 and positive 3. So we, and then we're also supposed to go through this point here. So we should be doing this. There's our parabola, there's our line. The parabola intersects the line at the points of intersection. And I've probably drawn this a little too vertical. It should probably look like it's going up and to the right. Okay. All right, good. The next question. This is probably the last one we get to today. And then tomorrow we'll finish up this. And then we will also, if you guys want to, look at the review. Number 15, we'll do, 14 and 15. So find the center and radius of the circle with the following equation. So my center is, or my equation is 5x squared plus 5y squared minus 10x plus 30y equals 30. So before you do anything else, if they say it's an equation of a circle, we know we don't want to have a coefficient of x squared and y squared that's other than 1. So if you got something times x squared, divide by that something. So divide by 5. So divide everything by 5. So we're going to get x squared plus y squared minus 10 divided by 5 is 2x. 30 divided by 5 is 6y equals 30. And then we're going to group the x's and y's together. So write this as x squared minus 2x plus, leave yourself a blank space for completing the square.
Don't you divide the 30 too?
Thank you. Yes. Exactly. I'd like to pretend I made that mistake on purpose. I did not. But yes, good eye, right? You're dividing everything by 5, especially the stuff on the other side. Not especially, also. And then we've got y squared plus 6y. Leave yourself a blank space to complete the square. On the right-hand side, you're going to have 6 plus whatever you add here, you have to add here. So what are we adding here? What's going to complete the square? Well, we have to take our negative 2, divide it by 2, and square it. Negative 2 over 2 is negative 1. Negative 1 squared is positive 1. Add it here, adding it there. What about here? What's the number that's going to go up here that's going to help us complete the square?
Is it 9?
Exactly. So I'm going to get, right, 6 divided by 3, 6 divided by 2, which is 3, and 3 squared is 9. Now here's the thing. This one definitely factors as x. So it's going to factor as x minus 1 squared. It's minus because it was minus there. And it's minus 1 because that's the number that's in here, right? Minus 2 over 2 is minus 1. This one is going to factor as y plus, right? It's plus because it's plus there. But it's not going to be plus 9. It's going to be plus 3 squared. Right? It should be whatever you're squaring to get 9. Oh, we're squaring 3 to get 9. So that's what we should have there. And then it's equal to 6 plus 1 plus 9, which is 16. So then our center is positive 1, negative 3. I'm always thinking about the values of x and y that make each of those 0. 1 minus 1 is 0. Negative 3 plus 3 is 0. So my center is positive 1, negative 3. My radius is the square root of this number over here, which is 4. And then we're asked to graph it. So to graph a circle, all I really need to see is the center and that you've gone the radial distance in each of the 4 normal directions. So if my center is 1, negative 3, and I'm going to have to go 4 to the right, 4 to the left, 4 up, and 4 down. So I'm going to mark off 1, 2, 3, 4 to the right, and then I'll go 4 to the right. You could label this point. You could label that point, right? That point would be 5 negative, but you don't have to, so I'm not going to. I'm going to go 4 up. So 1, 2, 3, 4. So 4 directly above. 4 to the left. So 1, 2, 3, 4. So right there. And then 4 down. So 1, 2, 3, 4. And then try to draw the best circle you can draw. That's all right. It's not great. If you want to, if it makes you feel more comfortable, you can certainly label these 4 points on the circle. This is 4 to the right, so we add 4 to the x coordinate. So 1 plus 4 is 5. 4 up, we're going to add 4 to the y coordinate. Negative 3 plus 4 is 1. 4 to the left, we're going to subtract 4 from the x coordinate. 1 minus 4 is negative 3. And 4 down, we're going to subtract 4 from the y coordinate. Negative 3 minus 4 is negative 7. These 4 points are not required, but if they make you feel more comfortable at what you've graphed, you're certainly welcome to label them.